Our first question is this. Solve the equation x to 3/2 equals, I think it was 8, correct?
Yes.
Okay. So this is an equation that actually it's a radical equation because every time, remember, every time the exponent is a fraction, this really means the square root of x cubed equals 8. However, you don't have to go this route if you don't want to. You don't have to change it from a exponential notation with a fractional exponent into a radical if you don't want to. So let's stick with this for now. I need to eliminate the denominator that is 2, so I will have to square both sides, which is basically the same thing I would do here. So I copy the base. What happens to the exponents? How much is 3 over 2 times 2 over 1? When you simplify the 2's, what do you get?
X cubed.
Very good. And the right-hand side is 64. Now, this equation from being a radical equation changed into what type of equation? What type of equation is this? Say it again.
Linear. No.
That would be x squared. So what type of equation is this? Does it have x in the denominator? No, so it's not rational. Does it have the absolute value? No, so it's not the absolute value. Is it linear? No, because the degree is, it's polynomial, of course. What degree?
3.
3. How many solutions do I have to present?
3.
That's it. So unless, I don't know what the requirements of the problem are, but the problem could request us to find only the real solution. If it asks us to only find the real solution, then I will take the cube root and I'm done. However, this is a polynomial equation. I know it has 3 solutions, mandatory. So I will move 64 to the other side. I have x cubed minus 64 equals 0. And we discussed this on the factoring. That's why factor is so important. Okay, so this is the difference of what? The difference of cubes. Once you say the difference of cubes, then I know you're going to give me a binomial and you're going to give me a trinomial. Let's start with the signs. If this is different, the difference, what sign do I have here? Good. What sign do I have here? That's it. And the last one is always positive. Good. So now I have to figure out what I cube to get x cubed and what I cube to get 64. That's all I need to do. Once I figure that out, it's, I'm halfway through.
So it's X.
Yes? Correct. X and 4. So now the pattern says this squared here, and this is the product. So, good? Very good. That's it. So one solution is clearly x equals from here. Good. And the other two will come from here. So let's write x squared plus 4x plus 16 equals 0. And what do I do? Remember we learned or reviewed 4 different methods of solving quadratic equations. This is not factorable. I cannot take the square root. I will not complete the square unless you force me to. So what is the only chance? Quadratic formula. So negative b plus or minus the square root of b squared minus 4ac. 4 times 1 times 16. It's wiser to keep it like this. Over 2 times a, which is 2. The reason why I don't want to multiply is because it's easier if I don't multiply and don't perform this operation, because I can factor out 16. And then I have 1 minus the square root of 4, which is negative 3. And that's easier than if I get a big number and then I ask myself, what do I do with it? So obviously they are imaginary solutions. 16 minus 4 times 16 is not going to be a positive number. It's going to be a negative number. So this is a real solution, and these two will be imaginary. So I have x equals negative 4 plus or minus. Inside the absolute value, I will factor out 16. So 16 times what is 16? 1 minus 16 times what is 4 times 16? Very good. So then x equals -4 plus or minus. I can take the square root of 16, which is very good. And then I have 1 minus the square root of 4, which is -3. So this will be I, the square root of 3, divided by 2. Any questions here?
Yes.
Go ahead, please.
With the 16, wait, 4 times 16 equals 1 minus 4. I don't understand.
16 times 1 is 16. 16 times -4 is this. If you perform the operation 16 minus 4 times 16 will be 16 minus 48, and you get -32. And now you have to go back and do something with the square root of -32. Instead, I notice that 16 is a common factor. I notice that once I take it out, I have 1 minus 4, which is -3, which is I the square root of 3. Or you can use this, and you will eventually get 4I the square root of 3. But this is more difficult. It's easier to notice that I can factor out, but it's the same thing. Is it clear how I got -32, in case you don't want to do this? Is it clear how I got -32?
Yes.
So it's 16 minus 48, correct? 16 minus 40 is -32. Okay, so now here's what I do. -32 can be rewritten as negative. So it's 6. That's 48, right? And this is 32. So what did I get here? Everything appears to be correct, but why am I not getting the same thing here? No, I'm asking myself.
Okay.
So this is -4 the square root of, I'm sorry, it's 4I the square root of 2. So what did I do here? So I'm checking now everything. Okay, so that's correct. -4 plus or minus b squared minus 4ac, that's correct, over 2a. That's correct. So I factor out 16, and I got 1 minus 4, which is -3. Oh, right, because it's not 48. This is not 48. Of course. Okay, now it's clear. So, so this is what? 48. That's why. Okay, and 48. Sorry about that. Sorry, I got carried away with the numbers. So then the square root of -48 equals the square root of -1 times the square root of 16 times the square root of 3, which is 4I the square root of 3. Exactly what we just got. But it's a longer procedure. So that's why I'm saying factoring can be used not only if you have variables or unknowns. You can use factoring to perform a calculation that is easier to simplify if you want, an expression, numerical expression that's easier to simplify than going this route.
So,
Yes,
how do you, so the 16 took out the other 16?
you're talking about here?
Yes.
Okay.
I'm not understanding that.
Okay, so we understand that if I have x minus 4x, I can factor out x, and I have 1 minus 4. And this is what I did. I factored out 16.
Okay.
So this was 16, I factor it out, and then I have 1 minus 4 inside.
Okay.
So because it was easier. But you don't have to do this. You can go this route. So then I took the square root of 16, which was 4. I know in here I have -3. So it's I the square root of 3. So these will be 2 more solutions, but I have to simplify. Remember I said do not make this mistake. You cannot simplify 2, which is a factor, with 4, which is part of a term. You cannot do that. So I can split into 2 fractions, -4 over 2 plus or minus 4i the square root of 3 over 2. That's the best thing to do. So x equals negative 2 plus or minus 2i the square root of 3. So we got a final three solutions, 2 solutions from here and 1 from here. So the only one was x equals 4, which was a real solution. These are imaginary solutions. Does it make sense? But again, I don't know what the problem was asking. Was it asking us to find all solutions?
I don't know, I didn't write it down.
Okay, so I don't know what, we have to look at the request. Good, next question. Yes.
All the way up from the beginning of the question. No, all the way down. No, what's x3 over 2 is equal to 8, right?
Yes.
If I'm trying to eliminate the x,
You cannot eliminate x. We're solving for x.
okay, solve for x.
Yes.
Am I right to say x3 over 2 in bracket multiplied by the inverse and
Let me write what you're saying because I'm not sure. So I don't want to answer something. So the equation is x raised to 3/2 equals 8. So what would you like to do to both sides?
Okay, what I'm trying to do on both sides.
Yes.
Is x3 over 2 multiplied by 2 over 3.
You mean raised to a power. You cannot
Yes.
multiply. Okay. So you want to say 2 over 3 here and 2 over 3 here.
Yes.
Very good.
Then I cancel on this side, I cancel both sides.
Right.
3 cancel.
But you only get one real solution. You will not get the imaginary solutions.
So this is wrong?
Depending on what the problem is asking. We don't know what the problem is asking. We're not sure. If the problem is asking find the real solution, you're fine. But if the problem says find all possible solutions, then you're not fine. So you have to be, was it in the book or?
Yeah, number 31, in section 1.6.
So you have to be very careful with these exponents. If it's an integer exponent, it's much easier to handle. If it's a 31 in 1.6. So when you eliminate the whole fractional exponent, you may get into trouble. So it's better to do it step by step. First eliminate the denominator, which is this, and then eliminate the numerator, which is all proposed solution. So there are 3 solutions there. Yes. But if you do this, you're going to get x equals 2. You're not going to get the other 2 solutions. So it's a very tricky situation. Every time we encounter something like that. Very good problem. Thank you. Okay, now you had one. Other questions on this? Okay. Now, I can go back for a second. I don't want to spend too much time on this because we have so much moving forward. So this is from section 1.6. I'm just curious. That's why I'm saying please read your text because I want to show you something here. This is way more difficult in my opinion than what I'm showing you in class. Here it says, if m is even, m being this number, if m is even, then blah, blah, blah. If m, which is this number, is odd, then blah, blah, blah. There's no need for that. There is absolutely no need for this. This is way more difficult. What I'm saying to you is eliminate the denominator first and then eliminate the numerator. If you do that, you will never make a mistake because you will identify the polynomial. If the polynomial, after you remove the denominator by squaring both sides, like we just did, you got a polynomial with degree 3, and you know that it has to have 3 solutions. But if you eliminate both the numerator and the denominator, you will not get all solutions. So always eliminate the denominator and then see what you get. I'm not saying that this is incorrect. I'm saying I think it's more difficult and you have to memorize stuff. Oh, if m is this, I have to do this. If m is that, I have to do this. There is no need. If you do it sequentially, step by step, as I showed it in class, this is useless. Good. So always eliminate like we just did. See, we squared both sides to eliminate the denominator. Then we got the polynomial equation, and from here we got 3 solutions. Okay? Versus eliminating the numerator and the denominator in one step. Okay, perfect. Next question. What was it? You had something with the absolute value, right?
Is 5x plus x.
5x plus
I'm sorry, 5x plus 10
10.
over 2
Yes?
is less than 15.
Very good. So we will look at this. Once we look at this inequality, we'll say it's an inequality with the absolute value. And it's completely cleaned up. You cannot do anything inside the absolute value. It's not allowed. So then, since it's already simplified, I'm asking myself, which type is it? Because there are only 2 possible types of absolute value inequality. One that changes into a sequence, which is inside, and the other one that changes into the outside, 2 totally separate inequalities. And the solution will have the union. So which one is it? The one with the inside, the easy one, or the one outside that will have the union? The easy one. Correct. Correct. The easy one. So how do I convert it? Because if I see, I don't do that. Don't correct anything. This I cannot solve. I don't know how. But if I'm able to, or I remember how to change it into simple or compound inequalities, then I can solve it. But right now I can't do anything to it. So solving this inequality is the same with solving which inequality?
It's like 5x plus 10 over 2 is less than minus
5x plus 10 over 2 is less than,
10. Is it correct?
but we just said it, it's not this one. This one will be less than negative 15 or greater than 15. We just said it's not this one. It's not. So then?
Less than 15 is less than, oh. 15 is less than.
Oh, I have to write the in between. Give me the in between first. I'm not done. You, great. Thank you. So this is inequality that says in between. I have to write this first, correct? So I replace that inequality that I don't know how to solve by this one that I know how to solve. But I have to write the correct starting point. And this is the starting point. Now what?
Multiply both sides by 2.
Yes, we multiply all 3 sides by 2. So negative 30 less than 5x plus 10 less than 30. Good. Then, that's what allow me to repeat myself. I know I sound like a broken record. But if you don't redo the problems we did in class first, as the very first layer, that's the starting point, you will have difficulties. And I don't want you to have difficulties. So please remember, redo the problems we do in class first. That's your first step. Okay, then you said to subtract 10 from all 3 sides, negative 40 less than 5x less than 20. And finally, you will tell me to, awesome. So this is negative 8 less than x less than 4. And this is the interval notation. Do not separate, for this particular one, do not separate into 2 inequalities because you will forget to intersect. We don't do that. Okay? Do not try to apply this method to the other one, or what you apply to the other one to apply to this one. It's not a good idea. Okay, so what is the interval? So I will say x in the interval.
C, negative 8.
Very good. Good. Is there anything else that you would like to ask? Other questions? Anything else? Please remember to redo the problems we do in class first. That's your first bet. That's your starting point. Okay, so let's go back and look at a function. And I'm going to pick a function from your book. I am interested in picking 82 on page 231. I'm going to copy the graph to the best of my abilities. And we may just simply read from my graph. That's fine too. So I have and 1, 2, 3. And here. Okay, here's the graph. Our first question is this the graph of a function? Bless you.
Excuse me, thank you.
Is this the graph of a function? How do I know? Because remember last time, this is where we looked at those three bubbles, and we said for each x there is only one y. For each x there is only one y. For each x there is only one y. The same thing here, function. For each x there is only one y. For this x only one y. For this x only one y. And the same when we got to this situation, we realized that 1 corresponds to 4, 10 to 4, which is okay, but -3 corresponds to 5 and -11. Okay? So how do I know if I'm given a graph, how do I know if the graph represents a function? Anyone remembers how to do this? By the, no, the other one. Yes, yes, by the vertical line test. What does it mean? Exactly like in the bubbles. If I cross the graph with vertical lines, each vertical line will cross the graph, will meet the graph in only one point, and then I will read the y value. So if I cross it here, it will meet the graph, it will touch the graph, or if you want cross or intersect the graph in one point, and I will read this y value. So by the vertical line test, is this the graph of a function? Yes. Because every vertical line will cross the function, the graph in one point. Good. So here is the next step. I would like us to find the domain of this function. Now let me refresh your memory on what the domain means. The domain is whatever I can replace x by. So from the leftmost point till the rightmost point where I see the graph. So from the leftmost point, since this is an open point, what will be the domain? Indeed, with a parenthesis, comma, 0, indeed, with a bracket. So the function exists only for x values between -6 and 0. Are we in agreement with that? Now, I would like to determine the range. The range is a different situation, right? We are looking at the y-axis now. And we imagine that we cross the graph with horizontal lines. So from the lowest y value till the largest y value will be the range of this function.
Bracket -3,
Yes?
comma, 4, parentheses.
Yes, because this is not a full point. Awesome. Very good. Okay, here's my next question. X-intercept of this graph, and then y-intercept. The x-intercept or intercepts are also called zeros of f of x, where f of x is the function, f of x, f of x. So does this function have an x-intercept? And what does the x-intercept mean? It's the point where, or points where, the graph of the function. Good. So I see that the function crosses the x-axis at this point, and I will state that the x-intercept is -4, comma 0. We prefer it in an ordered pair format, but if you just say -4, it's fine too. Okay. Now, can anyone give us the y-intercept for this function? How do I write it?
0, -3.
Yes, 0, -3, or y equals -3. Perfect. I have a next question. Stop me if you have questions. Anyone? This is clear, right? Okay. Yes? Any questions? Please stop me if you have questions. So now here's my next question. Find x such that f of x equals -2. Find x such that f of x equals -2. What does this mean? What is given in my question? So what is this? Is x the same with f of x? No. So y is the same with f of x. So then what is given to us at this point? Exactly. Now remember, how do I graph a vertical line? Well, x equals. The equation of the vertical line is x equals 5, x equals 3, x equals -2, right? But how do I graph y equals -2? That is a horizontal line. So I go back to the graph. I see where -2 is, and I draw a horizontal line. That is y equals -2. I realize that it crosses the graph in this point. So I will determine the corresponding x value. According to my graph, what would you say that when y is -2, how much is x? It appears to be -1. If I want to ask you, can you please give me the ordered pair that represents the point that we are looking at and we're reading from, what would you say? -1, -2. Awesome. Any questions? Okay, what if I say find f of -6? What would you say? Good. So indeed, x equals -6, which is a vertical line. Awesome. Yes. And how much is it? So I draw a vertical line at -6, and what do I say?
-6, the parentheses, -6 come
Look at the domain. F of -6. Look at the domain. What does this mean? Say it again. So when we say that when we use a parenthesis at -6, what does that mean? Exclusive. So let's come back. So when x equals -6, what is the answer? Very good. The function is undefined at -6. Has an open point. It's undefined at -6. Very good. Good. Anything else here? Other questions for me? Okay, let's see how we evaluate a function. Okay, let's suppose I'm given f of x equals, let's say, x squared minus 2x plus 4. And I'm asked to find f of 2. Then I'm asked to find f of 0. Then I'm asked to find f of 8 plus h. So these are the questions. I'm given a function. I'm asked to evaluate it for. What am I asked to evaluate it for the first time? What is this? I'm asked to evaluate when? When? Perfect. Exactly. When x is 2. What am I doing here? Good. And what is the last one? Awesome. Did you all hear? Perfect. So now, the very first thing I need to do is look at this function and ask myself, what does the function tell me? What does it say to me? And here's what the function is telling me. And I would like you to understand this because moving forward, this is very important. This function tells me this. This is the pattern. This is what it tells me. Okay? Which means, what goes in the box in the first case? What goes in the box in the second case? What goes in the box in the third case? That's it. Once I understand that, I can't make a mistake. So let's plug in 2 and tell me what to write. 4 minus, yes, plus, good. So the answer is, now if I ask you, please give me the ordered pair as if you would graph this function. It's not the case, but assuming that we are graphing this function, what will you write? Awesome. Please remember it's x comma f of x. For any point on a graph of the function, if this is the function f, this point P has x comma f of x. So this is the x, and this must be the corresponding f of x. So if I'm given a function and you say create a point, I cannot say, oh, 2 comma 5. No, 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 no. I can say 2, plug it in, and get the y value through the function, right? F of 2. Good. So can anyone give us the answer for f of 0? 0, 0, 4. Exactly. So the ordered pair for this situation will be indeed 0, 4. Agreed? Good. So now this is much more work than what we had before in the other two. So let's do this together. Please tell me what to write. I'm going to copy the function here one more time so I don't have to go back to this page from above. And we're asked to find f of a plus h. Knowing what the function is telling us, knowing what is going on here?
I think you're zoomed in. Oh, now you're not.
I don't know. I mean, I think I did it several times. Okay, so please tell me what I need to write.
C plus h squared
Very good.
minus 2 into a plus h.
With parentheses, mandatory.
That's what it's called.
Good. So now this is good, but it's not sufficient. I have to simplify it. And on the first day of classes, we made an agreement about the first quantity. Be very careful what you tell me. Yes, I'm ready.
H squared
Yes?
plus 2ah
Awesome.
plus h squared minus 2a plus 2h plus 7.
Good. That's what it is. So f of a plus h is this quantity. No one can further simplify it, and this is it, and you'll see what we do with this in the next section, which is 2.2. Any questions for me? Okay, I would like to ask you about a graph of a function. Here's the graph. We will talk about this graph in chapter 3 extensively. For now, I only want you to identify the domain and range. So here's a graph. Is it a function, first of all?
Yes.
Even a relation has domain and range. Yes, it is a function by the vertical line test. This is a function. So I would like you to identify the domain and range for this. Okay, sorry, I should have mentioned something here. So what do I write? Negative infinity, comma, good, union. Very good. You will see what happens in chapter 3 and what this function represents. Okay, now the range, please.
Oh, negative infinity.
There's a gap. Very good. There's a gap like it was here. Union. Very good. Right? We cannot, so that's why I showed this. I know it looks silly, but that I'm cutting the function with horizontal lines. Here I can cut it, but here I cannot. The function is not present here. And then I can continue cutting it, and it hits. Is that better? Do we understand this? Questions? Questions? Okay, so now here's a question for you, just a simple situation with just another graph. And let's say this is 1, 2, 3. This is 1, and this is -1. Does this graph represent the function? You cannot connect the points. Does this graph represent the function? Why? Because by the vertical line test, at x equals 1, the function, the vertical line crosses in 2 points. So therefore, it means that for x equals 1, we read y equals 1 as well as y equals -1. And this is what we discussed last time, right? So if I have 1 that goes to -1 as well as 1, this is a relation. Which means it's not a function. Does it exist? Yes. However, even relations have domain and range. Can anyone identify the domain for this function? I'm sorry, for this relation, forgive me, and range for this relation. X is very good. Here's how we write it. We cannot write parentheses or brackets because that will mean everything in between, not just the endpoints, but also everything in between, and that's not the case here. What about the range? So the range has -1 and 1 indeed. -1 and 1. Very good. So be careful. You may encounter some problems like this in which you have a graph that is only made out of dots. It's not, it could be a function or not, but you're not allowed to connect them. This is the entire graph. That's all we have. Yes, please.
You gotta write the little squiggly lines like that.
Yes,
Okay.
because when you list elements and there is nothing else in between, then you have to use braces.
Okay.
Yes. If I had something like this, like we have here, or let me give another example similar to that. If I had this situation, let's say between 1 and 3, I would have written that the domain was 1, 3. And the range is just this number. There is nothing else. But this means not just 1 and 3, but also everything in between. This one means only 1 and 3. This one has infinitely many solutions. I mean, not solutions, but x values, I meant to say, in the domain. This one only has 2. Just 1 and 3. Do we understand the difference?
Yes.
Which one is not clear?
The diagrams look the same, so what's the difference?
Infinitely many numbers between 1 and 3. 1, 3.
What about
1 and 3. When x is 1 and when x is 3. The function doesn't exist when it's 2 or 2.1 or 2.3, but this one does. By the vertical line test, this function exists anywhere between 1 and 3. This one exists, is a relation, first of all, but exists only at 1 and only at 3. You cannot connect the points if they're not given to you connected. Is that better? Do you see that this one has a graph and this one does not? If I ask you how much is here f of 2, you will find it's 1. How much is here f of 2? It doesn't exist, undefined. Is that better? Go ahead.
Why did they use braces for range?
Because there is only one value. If I want to cut it, it doesn't exist. It doesn't, it doesn't, it doesn't. Yes, it doesn't, it doesn't, it doesn't, it doesn't. There is only one value for y.
So if it was more than one.
I'm sorry?
And it was more than one, what is brackets?
Yeah, if I have, for example, this piece, for example, here, then I will say 1, 2. If I have an extension or a function that doesn't have a jump like that, then it depends on the function. But since this one had only one y value, I cannot create other y values. It's just one. Is this okay? Better? Okay, very good. So let's move on to the next section, which is 2.2, which is more on the same thing. More on graphs and functions. So we're going to look at more properties of functions, and what else can we figure out from a graph of a function. That's what we are trying to do right now.